Today's class is on the 7 magnificent tools for process quality improvement, where we will be talking about how to improve process by using very simple tools, very simple statistical tools. This list was initiated by Koro Ishikawa, 7 samurai and 7 weapons, and okay, Japan is known for those 7 things, and he gave the 7 magnificent tools. Remember this term, magnificent. He said as much as 95% of quality related problems in the factory can be solved with 7 fundamental quantitative tools. Why magnificent? Let's reflect. Write down in your notebook, make a mark in your notebook, how many of you had statistics and mathematics and numbers. Be honest. Make a mark in your notebook. The simple reasons that make these tools the magnificent 7. Number 1, it democratizes statistics. Democratize matlab it takes statistics to the general people, the aam admi, person who are not very up in the knowledge scale, to everybody, people like me. The next one, it makes statistical analysis less complicated for the average person. Okay, that's what I said. Next one is basically use of visual aids that makes statistical and quality control more comprehensible, more understandable. Okay, and the list is flowchart for making a process as it progresses. Cause and effect diagram, also called Ishikawa diagram, he gave this diagram, or fishbone chart. Okay, we'll get to know why is it called fishbone later on. And check sheet, it's a very simple thing. This is the most simple thing on earth, I guess. Very simple. Histogram, something which is common everyday life, you'll get to understand. The most interesting one, Pareto chart, which helps you identify the vital few causes and shift away the trivial many. And then the scatter diagram, where we try to find out the relationship between two variables, like do I have any relationship between my class students' height and their weight? I don't know, let's see. So that can be done by using what is known as a scatter diagram. And control charts for visual study how a process changes over time. And okay, this is slightly complicated, but anyway, we'll go it as along. Let's go one by one. The flow chart. I am giving you a very simple thing to just to check the process of checking whether you can start or you are willing to start the day in a happy mood, yes or no. Are you happy? If it is yes, very good, have a great day. Okay, go ahead. If no, would you like to be happy? Yes. In that case, I know that you are already happy. Go ahead, start the day, not a waste. You are not happy and you don't want to be happy, oh my god, that means something is wrong, man. Let's start it all over again. So this is basically a process, a simple process, nothing technical, but I can make it into a diagram. This is what is a flowchart. Okay, these are the technical things where we use traditional box, rhombuses and other shapes with appropriate connectors to chart out our process. And depending on users, different type of flowcharts with related shapes and symbols may be developed. And whenever required, you can modify. And then we actually have to check whether it is okay or not. Let's reflect. I'm giving you 2 assignments. Make a flowchart for number 1, you coming from your hostel to attend my class today. And number 2, make a flowchart for preparing a net-based assignment where you will need the internet connection and have to give me a printed report by a certain deadline. Okay. Next is the cause and effect diagram. As I said, it's also called Ishikawa diagram or fishbone. Identify the problem, place it on the head. Draw the spines and bones. This is my problem, absenteeism. Nothing to do with operations, everything to do with HR. Okay, let's try. This is my spine and those are the bones. Okay, it already started to look like a fish bone with a head, spine and bones. Identify major areas where problems may arise from. Health related, absenteeism due to family related problem, transportation, weather related. Next, identify what specific cause could occur within these areas. Health related, maybe my high temperature, fever, upset stomach. Okay, I had something wrong last night at a party. Accident, and maybe I'm hospitalized due to something serious. Family related, my child is unwell, my wife is not well, I have some rituals in the family, maybe a wedding, maybe something like that, or a social visit due to some religious festival, or okay, India is a place of festival, I need to go to my in-laws, my own family. Next, it can be weather related, flood, like in Chennai recently, cyclone, which almost every year hits the Visakhapatnam coast, extreme heat like the central Indian area, and heavy rain like the northeast. And then transportation. Okay, this is something we Indians are very much familiar with, transporter strike. My carpool failed, he failed to turn up, I had a flat tire, or my car broke down. So these are basically the reasons why I may have absenteeism in my office. So the boss will make a record how many people were absent throughout the year because of which reason. Let's reflect. How many of those causes are relevant for the previous reflection on hostel to class assignment? Okay, and let's reflect on why you could not submit the net based assignment on time. Give me a list. So basically I am trying to use this list with your thinking. Let's go ahead. The most simple thing on earth, the check sheet. Heavy rain in January. I had 3 absenteeism in my office. Not me, the whole office staff. Amongst the whole office staff, there was a total cumulative of 3 absenteeism in January due to heavy rain, and highest was somewhere in June where I had lots of them. And throughout the year there was 79 absenteeism in my office, where some or the other person was absent due to heavy rain. Upset stomach accounted for 74, car broke down accounted for 63, and so on. This is one type of check sheet where you use telemark. 1, 2, 3, okay, 4, 5, fine. Next is another type where we put a tick mark when a certain work is done. I go to a car service center for getting my car checked. He checks the coolant level, check, battery level, check, engine oil, check, and so on. Now right now I guess he is checking the tire pressure. He will put a check out here. Next, windshield wash water, tick out here, front lights, rear lights, and my car servicing is done. So this can be another check sheet. Very simple. See, that's statistics. Next is the histogram, where we collect the frequency of occurrence of each cause identified by the fishbone diagram. This list, this there's a list, this there's a number. So what I do is I make a visual of that number and the list. High temperature, there were about 12 occurrences, upset stomach, so many occurrences, accidents, so many occurrences throughout the year. Alternately, I can from a data set I can compute the sum, the mean of that is x, mean of x, the max, the mean, and from here the range, and then I can make a diagram and place these frequencies on a bar chart, or what is known as a histogram, which we learned maybe in our class 6, 7, 8 middle school. Okay, next we go to the Pareto chart, the most interesting one, where from this list which one are more important. Okay, you may say that this is very infrequent, not so important, this are important, but where do I make the cut mark? I mean, I just cannot make a line like that. I just cannot make a whimsical line like that. I just cannot make a cut. So whatever is above I'll take, whatever is below I will not take. So I mean, this is not whimsically done. So what I do is I go on what is known as the Pareto's 80-20 principle, where I sort the frequencies on descending order and plot a cumulative frequency line. That's what I did. Heavy rain accounted for highest, upset stomach this much, car broke down, just check. Heavy rain, highest, upset stomach, car breakdown. So this list I make a descending order sorting. Then I make a cumulative line. This is the cumulative line, and mind you, it has got a different scaling as this. This is my cumulative total scale. So please don't be confused with this. This I total, and the total goes to 600. So there was a total of 600 absentees in the last 1 year. I make a horizontal slice at 80% of cumulative total. That's it. 8 6 is 48, so around 480 I make a horizontal slice. Drop a vertical from the point of intersection. That's it. So whatever is within the box, those are the vital few which are of concern. So I'll take this one. Okay, I may take on your choice, no hard and fast. And these things are the trivial many, so don't worry too much about them unless there is something. Let's reflect. Can we apply this to find a major reason why you missed my assignment deadlines, that internet assignment deadlines? Which one are the most important reasons? I said I may neglect this, but are you sure that you can neglect this? So what I do is I check a scatter diagram to identify two causes that might have a relationship and plot the two on a XY plane like this: extreme heat and hospitalized. Who is hospitalized? It's out here. Where is extreme heat? Extreme heat, yeah, it's out here. So extreme heat is within the list, hospitalized is outside the list. So can I neglect hospitalized and consider extreme heat? But extreme heat causes hospitalization, which means these two are related. So I don't know whether I can actually neglect this. That's a scatter diagram where I try to find out if there is a positive correlationship or if there is a negative correlationship or if there is no correlationship, like that, when I cannot make a straight line. Next comes to the control chart, where one of the major causes that has a time related occurrence. Now what is this time related occurrence? I go back to the, yes, here, January, February, March, April, May. This is my timeline. Occurrences of heavy rain, 3, 2, 5, and so on. So there is a time related occurrence. So I can use heavy rain to plot that, upset stomach to plot that. But heavy rain, well, I cannot control it, so forget it. Upset stomach, maybe I can control it. So I'll plot this, something like that. Alright, and upset stomach is what I am using. And then plot time on x-axis and the number of occurrence on the y-axis, thereby constructing a run chart. That's it. That's my run chart. That's my run chart on these things. January 10, February 8, March 9, like that. Calculate the control limits and place them on the run chart to convert it into a control chart. Now what is this control limits? The central line or the mean or the average? The central line, the average out here is almost 6.2, something like that. I put it out here. The central line. Upper control limit. Now how do I put the upper control? That's something we'll do it in a statistical class, something else, where we try to put 3 times standard deviation out here or some number. And another one is the lower control limit. Now these two gaps are the same, exactly the same, 3 up and 3 down, 3 standard deviation up and 3 standard deviation down. This is the lower control limit, this is the upper control limit, and I check whether my process is within these two control limits or not. So basically that's a control chart. So what I did is I converted a run chart into a control chart. Now interpret on the process. If it is within control, yeah, it is within control, nothing is going out, there is no continuous. So there are different ways by which I can interpret it. Again, a reflection. Let me ask you, during the cricket season, the IPL season, or the World Cup season 2020, where do you see these run charts? Tell me, are you guys still afraid of statistics? Let's summarize. Don't say statistics is tough, because I need to keep it simple. That's what Ishikawa had propagated when he based his work on this. Systems perform best when they have the simple design rather than complex ones. My statistics is simple. Our statistics is simple. We kept our statistics very simple. something which Einstein also said. Okay, Occam's razor is something in the 4th century. It's a 4th century theory. This I have taken from net. So I end up with a case to you. Keep it simple, stupid. I kept it simple. We kept it simple. Statistics is simple. Thank you. Thanks for your time. Goodbye.